Welcome to this video on equivalent fractions. Equivalent fractions look different numerically but represent the same value or amount. Now this might sound a bit complicated, but hopefully it will become a bit clearer as the video goes on. Let's start with a pizza. So here I've got a whole pizza and the line down the middle cuts it exactly into two equal pieces, so two halves. Now, if in the school canteen you were given 1/2 as a portion for your lunch, then you would get exactly the same amount if that pizza had been split into 4 and you got 2 of those 4 slices. So you get exactly the same amount of pizza, whether that pizza's been cut into 2 equal slices and you get 1 piece, or 4 equal slices and you get 2 of those pieces. You get exactly the same amount of pizza. So we say that these are equivalent, and the fractions would be written like this. 1/2 is equal or equivalent to 2 quarters. It's exactly the same scenario if you had that pizza and you split it into 6 equal pieces. And if in the canteen you were given 3 of those 6 equal pieces, you'd still be getting half a pizza. So we say 1/2 is equal to 3/6, or 1/2 is equivalent to 3/6. And similarly, if that pizza was split into 8 equal pieces and you got 4 of them, you'd be still getting exactly the same amount of pizza. You'd be getting 1/2, which is equivalent to 4/8. So let's have a look at that in more detail. So here I've got 2 diagrams. Here my diagram is split into 5 equal pieces, and we know to put that on the denominator, that 5, and 2 of them are shaded in yellow. Here my diagram is split into 10 equal pieces, and how many are shaded? 4. But you're getting exactly the same amount of that shape being coloured in yellow. So 2/5 is equivalent to 4/10. If we're looking at this numerically, what's going on here? Well, 2 has been multiplied by 2 to get 4. Now, it should always be exactly the same thing that's happened on the bottom. Have we times by 2 on the bottom? Let's check. 5 multiplied by 2, yes, it equals 10. So whatever you're doing to the top, in this case timesing by 2, must also be happening on the bottom. We must be multiplying by 2. So you can be multiplying by anything, and we'll see some examples of that shortly. It doesn't always have to be 2, it can be any number as long as you're doing the same thing to the top and the bottom. And that's how we generate equivalent fractions. Here on the left, I've got a circle that I've split into 4 equal pieces, 3 of which are shaded. I've got an exactly the same size circle on the right hand side, but this time I've split it into 12 equal pieces, but I've coloured in exactly the same amount. So how many 12ths is that? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 of those blue slices there gives me exactly the same proportion of the circle shaded as on the left. What's going on numerically? Well, let's have a look. What have we multiplied 4 by on the bottom? We've multiplied it by 3. Whatever we do on the bottom, we must do on the top. So let's check, has this been multiplied by 3? 3 times 3, yes, it's 9. So 3/4 is equivalent to 9/12. Here, my diagram on the left is split into 3 equal pieces, one of which is coloured in purple. And on the right, exactly the same sized rectangle, this time split into 12 equal pieces. And by shading in 4 of them, I get exactly the same amount of that rectangle coloured in. And how many are there coloured in purple there? 4. So 4/12 is equivalent to 1/3. What's going on numerically? Let's have a look. That's been multiplied by 4. So the top should also have been multiplied by 4. Yes, 1 multiplied by 4 is 4. So, as I started off this video with, the definition of equivalent fractions being that they look different numerically, but they represent the same value or amount. So let's look at that with this example here. 1/3 is equivalent to 4/12. So they look different numerically. 1/3 looks different to 4/12. But if we look at this diagram here, we can see that it actually represents the same amount. Okay, that line of purple, that block of purple there, is exactly the same size as this block of purple over here. So they look different, the numbers look different, but the value or amount is exactly the same. Okay, so let's remember that rule with equivalent fractions. Whatever you are multiplying through by, either on the top or the bottom, must be the same. So here I've got the denominators, so therefore I'm going to ask myself, what have I done to this denominator to get this denominator? I have multiplied by 2, and whatever I've done to the bottom, I must do to the top. And what I mean by that is you have to multiply this numerator by 2. 1 multiplied by 2 is 2. So 1/4 is equivalent to 2/8. Here I've been given the denominator, so I have to say to myself, what's happened to that denominator of 7 to get to 35? It's been multiplied by 5. And whatever you do to the bottom, you must do to the top. Now, a few students tend to put the 5 in there, but that is not correct. You must multiply this numerator by the 5 to get 10. Here, 6 has been multiplied by 4, so therefore the 5 has got to be multiplied by 4. Don't fall into the trap of putting 4 here. It's 5 multiplied by 4, which is 20. What's 9 been multiplied by to get 108? 12. 9 12s are 108, so whatever I do there, I have to do to the top, but it's the 7 that I'm multiplying by 12, and 7 12s are 84. Okay, slightly different scenario here now. We don't have the denominator, but the same rules apply. Whatever you have multiplied through by, either on the denominator or the numerator, must be applied to the other one. So here, my numerator of 1 has been multiplied by 6 to get to 6. So I must do the same now to this denominator. That now must be multiplied by 6. So 2 6s are 12. So 1/2 is equivalent to 6/12. What have I done to the numerator here? I've multiplied it by 4. So I must do the same to the denominator. That must be multiplied by 4 as well, and that gives me 20. What's the numerator been multiplied by here? 5. So 12 must also be multiplied by 5 to get the new denominator of 60. What's 8 been multiplied by to get 96? 12. So therefore, I must do the same to the denominator. And 11 12s are 132. And the final situation is this one. So now we've got a denominator missing, but from the original fraction. But I'm still going to think about what's happened to the numerator. So here, what's 1 been multiplied by to give 5? Well, it's been multiplied by 5. So I've got to think, what number do I multiply by 5 to get to 20? And the answer to that is 4. And you can also think about it the other way around. So 20 divided by 5 gives you 4. What have I done to 8 to get to 16? I have multiplied it by 2. So what number do I multiply by 2 to get 18? I multiply 9 by 2 to get 18. And again, you could do 18 divided by 2 to give you this. 5 has been multiplied by 9. So what do I multiply by 9 to get to 72? I multiply 8 by 9. So again, you could do 72 divided by 9 to give you 8. And here, 4 has been multiplied by 11. What's been multiplied by 11 to give me 77? 7. So you can see with equivalent fractions, you can multiply by anything, 5, 2, 9, 11, just as long as whatever you're doing to the bottom or is the same as what you do to the top. Or whatever you do to the numerator is the same as what you do to the denominator. Okay, here are a few questions for you to have a go at yourself. And I've put a little timetables grid in the top right hand corner to help you. So pause the video now, have a go at these, write out both the original fraction and its equivalent, and then resume the video to see the answers. And here are the answers. Very well done for having a go at those.